Hey everyone, it's Justin again. Since the start of this unit, we have focused on all the different ways we can interpret features of graphs and the relationship between graphs and other forms of math problems. In this video, we'll finally be using all that knowledge to create our own graphs. Alright, first problem. A monthly cell phone plan costs a $10 flat fee and 25 cents more for each minute used. So if we want to graph this, we need to understand what the values we've been given are. So what is a flat fee? Well, that's the amount you have to pay even if you don't use any minutes. In other words, if you use 0 minutes, you still pay $10. That gives us a point that we can plot on our graph. And that point happens to be the y-intercept. Well, what about the 25 cents? You have to pay 25 cents per minute. So let's use that to find a second point. 25 cents for each minute means that if we used 4 minutes, it would add $1. So if we use 4 minutes, it would cost $11. Hey, wait, that 25 cents per minute gave us a rise and a run. It was the slope. I guess we could have figured that out since it was a rate. But anyway, now that we've got 2 points, we can draw a line through them, and here's our graph. We can check it by comparing it to the word problem. Even with no minutes used, you pay $10, and the slope is 1/4, or 1/4 per minute. Next one. A train is traveling 6 miles per hour towards the station, but is still 30 miles out. Let's do what we did on the last problem. First, what's the y-intercept? At the moment before any time passes, the train is 30 miles away. So the y-intercept is here at 0:30. 6 miles per hour is obviously a rate, so that will be the slope. But we have to be careful. If the train is coming towards the station, then its distance away is going down, not up. So the slope is actually -6 miles per hour. To graph it, we can use rise over run. The rise is -6 and the run is 1. So here's another point, and we can draw a line through them. So here's the line that goes with this word problem. Next one. A plane takes off from a runway and rises 50 feet per second. 50 feet per second will clearly be the slope. But where's the y-intercept? The y-intercept has to represent what happens before takeoff, but the problem doesn't need to tell us the y-intercept because it's common sense. Before takeoff, the plane is still on the ground. So its height is 0 feet. And from there, we can use the slope, 50 feet per second. So the plane's height increases 50 feet for every 1 second that passes. Now we can draw our line through these points. All right, last one. Carlos has a business fixing laptops for $20, but he won't break even until he fixes 7 laptops. $20 per laptop is a rate, so there's no question that that's the slope. So that makes 7 the y-intercept, right? Well, hold on, let's think about it. The y-intercept is how much Carlos has made before he fixes any laptops. So is that 7? No, we don't know how much he had before fixing any laptops. We know at what point he breaks even. In other words, if he fixes 7 laptops, his profit will be 0. So this is actually the x-intercept. Let's plot that x-intercept first, and then use the slope of $20 per laptop. And here's our line. Graphing is going to become extremely important from now on, so knowing how to represent any problem on a graph is crucial. The next unit will focus on different forms of equations and how to graph those, just like we graphed these word problems. Hey, hey.